Okay, this is part two video. Now, understand, guys, I mean, you're going to have to bear with this for 2 days, today and then probably Friday. Um, I don't know how else to do this. I So I just think this, to me, this is kind of the best way to look at this and do this. And if you can watch this, understand this, don't worry. When I come back, we're going to go through a lot of this stuff together. So it's not like I'm going to test you right away on this stuff. Um, but I want to go through these examples together. These are similar to examples you're going to see somewhat on your practice problems. Okay, and the first part is being able to identify sample space. Okay, so on your sample space, remember your sample space is all the possible, you have to list out all the possible outcomes. And if you remember right, sample space is always done with the two little braces, like so. Okay, so the sample space for a score on a test, I need to know all the possible scores. So in this case, I'm not going to list out all the single numbers. So I could get a 0, that'd be the lowest score, and I can get all the way up to 100, that's the highest score. Okay, so that's the sample space for a score on a test. What's the sample space for rolling a die? Well, if I take one die, there is 6 possibilities. I could get a 1, a 2, a 3, a 4, a 5, or a 6. So my sample space is a 1, 2, 3, 4, 5, and 6. Those are my possible things that I could get if I roll a die. A coin toss. What's the sample space for a coin toss? Well, there's only 2 possibilities on a coin toss. You can either get a heads or you can get a tails. That's my sample space for a coin toss. All right. Sample space for free throws made for a 2-shot try. Okay. So I'm at the free throw line, I'm shooting 2 shots. What are the possible outcomes that could happen? Well, I could make 0 of them. I could make 1 out of 2, or I could make 2 out of 2. So that is the sample space for the free throws. Okay, so this gives you an idea of kind of how to find sample space of probabilities. Okay, let's take a look at question number 2 then. Question number 2 is finding the theoretical probability of the following things. Okay, so the first one's kind of hard for me considering I'm sitting in my living room right now. But let's say, for example, let's say we had 23 people in the classroom total. Okay, 23 in the classroom total, and there were 15 males. Okay, so what's the probability of you choosing a male? Well, there's 15 males total, and there's 23 total students. Okay, 15 out of 23. That would be just an example. Okay, now what's the theoretical probability of you rolling a 4 on a single die? So the question is, I need to know the number of 4s on a single die divided by the total number of possibilities. Well, there's only one 4, so the total number of 4s, there's one 4, and there is 6 possibilities because it could be a 1, a 2, a 3, a 4, a 5, or a 6. So the probability of you rolling a 4 on a single die is 1 out of 6. Now, we could convert these to decimals. This would be 0.16. Okay, like so, all right? Or we can leave them as fractions, but if we leave them as fractions, we want to reduce them. Okay, so rolling at least a 4 on a single die. At least a 4 means I could roll a 0, or excuse me, not a 0. Can't roll a 0. I could roll a 1. I could roll a 2. Or I could roll a 3. At least a 4. Okay? Excuse me, I screwed that up. Never mind. At least a 4, okay, is 4 and above. Duh. So I could roll a 4, I could roll a 5, or I could roll a 6. So how many possibilities are there of me rolling at least a 4? Well, there's 3 possibilities that could happen. And how many possibilities total are there? There's 6, which this would be 0.50. Okay, drawing a face card from a deck of cards. All right, for those of you guys who don't know, a face card is, example would be like a king, queen, jack. Those are face cards in a deck of cards. How many cards are there in a deck of cards? If I was in class right now, I'd be getting crazy answers on probably knowing the number of people who don't know the number of cards in a deck. Well, There's 52 total cards in a deck. Okay, 52 total cards. There's 4 suits. Okay, 52 total cards, there's 4 suits. You have you have hearts, diamonds, spades, and clubs. There's 4 suits. There's 13 cards in each suit. Okay, there are, in this case, there are 3 face cards in each suit. So there's a total of 12 face cards in the whole deck. So 12 out of 52, which would be a 0.23. Again, the number of items you have divided by the total number of items. Okay, so that gives you an example of just finding some basic theoretical probabilities. All right, are the following events mutually exclusive? In other words, are they disjoint? Are they completely separate of one another? Okay, so as we talked about before in our notes, we talked about mutually exclusive events. Mutually exclusive events are two events that have no outcome in common. Okay, so rolling a 3 on a die and rolling a 5 on a die. The question you have to ask yourself is, can you roll a 3 and be a 5 at the same time? And that is a no. So, because that's a no, these things are mutually exclusive. They are disjoint. They are not tied together. Mutually exclusive means they're only part of one group. Okay? All right. Randomly selecting a male student and randomly selecting a nursing student. So the question is, can you be a male student and a nursing student at the same time? That answer is yes. You could be a male student and a nursing student at the same time. So these guys are not mutually exclusive. They're not mutually exclusive because you can be in 2 groups. You can be counted twice, essentially. Okay. Randomly selected a blood donor of type A and randomly selecting a female blood donor. Can you be of type A and be a female at the same time? That answer is yes. So these guys are not mutually exclusive. Okay, so these are examples that you'll be seeing on practice problems. Okay, so now I've given you a table here. It says the following poll of 1,008 students at Bellevue West shows students' preferred fast food restaurant. If we select at random from a sample of 1,008 students, what is the probability that the following things happen? Okay, so the key number here is that you know is 1,008. Why is that a key number? Because 1,008 is the total number of students that were surveyed here. Okay, 1,008 is the total number of students. So I want to know what the probability is, choosing at random, what's the probability that a person selected responded Chick-fil-A? Okay, so now as I look at this example, how many people chose Chick-fil-A? Well, that was 347 chose Chick-fil-A. Out of how many total? Well, that's 1,008. So that's the probability, which happens to be a 0.34, which essentially is 34% of the students, or of the 1,008 students, selected Chick-fil-A. Okay, now, next problem. There's a key word in the next problem. It wants to know what's the probability that the selected person responded Arby's or Sonic. Key word here. Or. Okay, or. Or means we add or we multiply. That's the question here. If you remember right, when we see or, that means we're going to add. These two things are separate things. So the probability of the people selecting Arby's was an 87 out of 1,008. And we're going to add that to the probability of the people from Sonic, which is an 85 out of 1,008. Which, when I add those two together, I get a total of 172 out of 1,008, which is 0.17, or about 17%, chose Arby's or Sonic. Okay, third one. Third one says, what's the probability that the selected person responded not Taco Bell? Okay, well, if you chose not Taco Bell, then in other words, you chose everything else. So I would take let's see here, the 347 from Chick-fil-A plus the 87 from Arby's plus the 85 from Sonic plus the 80 from Runza, which that gives me a total of 599. So 599 chose not Taco Bell out of 1,008 total, okay, which is approximately 0.59 or 59%. This is an example of using the not the 1 minus essentially. So I could have taken and done 1 minus 409 over 1,008 and gotten 599 as well. Okay. All right. So hopefully these examples here will give you a head start on what you're doing with your practice problems. So take a look at those today. The Chapter 14 Worksheet A practice problems. And if you've got questions, please don't be afraid to email me and I will try and get back to you as soon as I possibly can.